All right, everybody, welcome to 5.6 half-angle identities. This is the last section of chapter 5. All right, we're going to derive 5 different half-angle identities in this section. We'll start with deriving the half-angle identity for sine. To get us started, let's write down our identity for, we've already derived this one. It's the double angle identity for cosine. Remember there's 3 different versions for the double angle identity for cosine. Let's write down the one that is written in terms of sine of x. Yes, this one. Cosine of 2x is equal to 1 minus 2 times sine squared of x. What I would have us do here is solve for sine of x. Isolate sine of x. So maybe add 2 sine squared of x to both sides. And then subtract cosine of 2x from both sides. All right, good. And then I think what we can do now is divide both sides by 2. I'm talking about for this 2 here in order to isolate sine of x or sine squared of x. All right, very good, guys. Be careful here. You cannot divide out these 2's right here. That's just not allowed. Okay, this 2 belongs to the argument of this function, so be careful. All right, cool. Let's take the square root of both sides. All right, so we have sine of x is equal to plus or minus the square root of 1 minus cosine of 2x over 2. All right, we're going to make a substitution at this point. This is the substitution I would like us to consider. Let 2x equal a. Let 2x equal a. That would lead you to x is a over 2. So this would be replaced with a over 2. That's a half angle. And this is going to be replaced with a. All right, so with this substitution, you would have this half-angle identity, all right? You ready for this? Sine of a over 2, that's a half angle right there, folks. Sine of a over 2 is equal to plus or minus the square root of 1 minus cosine of a over 2. There it is. That is our first half-angle identity for sine. Okay, cool. That wasn't too bad. Let's derive the half-angle identity for cosine. Okay, so we'll start at the same point, the same starting point as before. Cosine of 2x is equal to, but this time around, I'm going to write down the double angle identity for cosine in terms of cosine. So cosine of 2x is equal to 2 times cosine squared of x minus 1. We already derived this identity in a previous lesson. Now, what I want us to do is to solve for cosine of x. That is to say, isolate cosine of x. Now, what you might want to do first in order to isolate cosine of x is add 1 to both sides. After adding 1 to both sides, let's divide both sides by 2. Okay, cool. Just another word of caution here. Please do not divide out these 2's. That's not allowed. All right, let's take the square root of both sides. And we will have cosine of x is equal to plus or minus the square root of 1 plus cosine 2x over 2. We're going to make the same substitution as before. That is to say, let 2x equal a and let x equal a over 2. And we're going to substitute this in, okay? So let's do that now. And then this leads us to our half-angle identity for cosine. Cosine of a over 2, that's the half angle, a divided by 2, is equal to plus or minus the square root of 1 plus cosine a over 2. Notice that the only difference between the half-angle identity for cosine and sine is the sign right here. For the half-angle identity for sine, it was 1 minus cosine a over 2. This one's 1 plus, so just keep that in mind. All right. Cool. Let's derive the half-angle identities for tangent. Now, there'll be 3 different ones. Okay, I'm going to walk you through them. Okay, so tangent of a over 2 is what you and I want to derive, okay? Now, a quotient identity, the quotient identity allows us to rewrite this as, as sine of a over 2, right? Divided by cosine of a over 2. That's the quotient identity, isn't it? Now, you and I know what the numerator is, and you and I know what the denominator is. We just derived those, so let's substitute those in. Okay, so we derived this already, these two expressions, for half-angle identity for sine and cosine. All right, so we know that this is equivalent to the following. We know this by the quotient rule for radicals. So then, actually, let me come down here if you all don't mind, to make sure I have some space here, to make sure I have enough space. So then this is plus or minus the square root of 1 minus cosine A over 2 times 2 over 1 plus cosine of A. All right, so you can see now that these 2's divide out, and so the half-angle identity for tangent is going to be, all right, equal to plus or minus the square root of 1 minus cosine A over 1 plus cosine A. And all of this is underneath this radical here, okay? This is the first half-angle identity for tangent. Okay, cool. Let's derive another version of the half-angle identity for tangent. So tangent of, let's see, tangent of A over 2 is what we're looking for, right? And let's say that this is, let's do the same thing as before. Quotient identity says this is sine of A over 2 over cosine of A over 2. All right, that's the quotient identity. That's the same thing that you and I did a little while ago. Now, what I want us to do is multiply this whole expression by 1. You know, whenever you multiply an expression by 1, it does not change the value of that expression. However, I want the number 1, the value of 1, to be written in the following form. Okay, I want us to multiply the numerator and denominator by 2 times cosine of A over 2. When we multiply the numerator and the denominator by the same expression, we're really, in essence, multiplying by 1. All right, so then what we're going to get in the numerator is, let's see, you're going to get 2 times sine of A over 2 times cosine of A over 2. That's going to be your numerator after multiplying. And then the denominator is going to be 2 times cosine squared of A over 2. That's what you're going to end up getting. All right, now I want to take your attention over here to the side for a little bit, because I want to talk to you a little bit about, or remind you about a couple identities that we have. So recall these two identities that we've derived already in previous lessons. Sine of 2x is equal to 2 times sine x cosine x. Let's just talk about that one for a second, okay? Just this one. Notice that your numerator here is of this form. That means this numerator can be rewritten like the left-hand side of this identity. Sine of 2 times whatever your argument is. See this argument x? There it is right there. So then the double angle identity for sine says you can rewrite all of this right-hand side as sine of double your argument. Okay, so that must mean then we can rewrite this numerator here as sine of double my argument. Did you catch that there? Now what about this denominator? 2 times cosine squared of A over 2. Well, look at this. Cosine of 2x, we've already said that that's equal to 2 times cosine squared minus 1. Let me move up a little bit. What that would mean then is that, you know, if I add 1 to the left-hand side, that cosine of 2x, well, actually, let me write it like this. Let me rewrite it like this. If I add 1 to the left, I'll have 1 plus cosine 2x is equal to 2 times cosine squared of x. Right? Now this is important because look at your denominator. Your denominator is 2 times cosine squared of something. 2 times cosine squared of something. That follows this form. 2 times cosine squared of something. That must mean that this denominator can be rewritten as the left-hand side, which says 1 plus cosine of double that something, double your argument. Okay, then that means this denominator here can be rewritten as 1 plus cosine 2 times your argument, like that. Okay? So, what you have now then in this identity is you have sine of A, because those 2's divide out, right? And then over here you have 1 plus cosine of A. This is another identity for half-angle of tangent, half-angle identity of tangent. All right, so far we have 2 different versions for the half-angle identity for tangent. Now, let's get the last one. The last one for tangent of A over 2 is going to be the following, okay? Let's start with what we just finished deriving, tangent of A over 2, right? We now know that it is the same thing as sine of A over 1 plus cosine of A, right? We just derived that, okay? It's right here on the screen, okay? But what I want you to do is multiply by 1 in the form of the conjugate of the denominator over that same conjugate, okay? That's multiplying by 1. All right, what would you get? Well, the numerator, you would get sine of A times 1 minus cosine A. And in the denominator, you would get 1 minus cosine squared of A, right? And by your Pythagorean identity, we know that this denominator is equivalent to sine squared of A. So then the sine A's divide out, leaving you with just one of the sine A's in the denominator, right? So then this is just 1 minus cosine A over sine A. And this is the third and final half-angle identity for tangent. Cool. We did it, you guys. We did 5 different identities. That's what we just finished deriving. One half-angle identity for cosine, 1 half-angle identity for sine, and 3 half-angle identities for tangent. Okay, example 1. Find the exact value of sine of 22.5 degrees. If you punch this into your calculator, you'll get an approximation, not an exact value. So let's do this by hand. Find the exact value of sine of 22.5 degrees. Now, let me write down for us the identity that we just derived for the half-angle identity for sine. Because 22.5 is half of one of our special angles. 22.5 is half of 45. 45 is one of our special angles. So this is what we're going to do. Let me remind you that sine of A over 2 is equal to plus or minus the square root of 1 minus cosine A over 2. All right? Now, the angle that we have, that they gave us, is 22.5 degrees. But 22.5 degrees, 22, let me write that down, 22.5 degrees is the same thing as, or equivalent to, 45 degrees divided by 2. Like that, right? So I'm able to rewrite the angle they gave me as a half angle. And now I can use my identity. When I use my identity, my half angle identity, when I come across A is the same thing as 45, right? So wherever I see A in my identity, I'm going to replace it with 45 degrees. All right, I think we're ready to do it, guys. Let's do it. So sine of 22.5 degrees is equivalent to plus or minus the square root of 1 minus cosine of 45 degrees over 2. Cool. All we have to do is simplify this expression, and then we're done. So then this is plus or minus. Wait, you know what? Let's go ahead and choose the sign right now. Is it plus or minus? Well, it all depends in which quadrant this angle that they gave us lies. 22.5 degrees is in quadrant 1. Therefore, since everything is positive in quadrant 1, we know we can take the positive square root. So this becomes 1 minus root 2 over 2. That's what cosine of 45 degrees is, over 2. Okay, so let's simplify this expression. Can't leave it like that. So then we get, let's see, what do we get here? We get the square root of 2 minus root 2 over 2 over 2. And all of this is underneath 1 square root, which is equal to 2 minus root 2 over 2 times 1/2, right? This is all arithmetic. So then you get the square root of 2 minus root 2 over 4. All of this is still underneath the square root. So we can evaluate by the quotient rule of radicals. We can evaluate the square root of 4 in the denominator. And so our final answer will be the square root of 2 minus the square root of 2, and then all of this over 2. This is the final exact answer for sine of 22.5 degrees. 22.5 degrees. Isn't that pretty cool? All right, let's go to the next example. Find the exact value of tangent of 75 degrees. Okay, guys, once again, 75 degrees is not one of our special angles, but 75 degrees is half of one of our special angles. 75 degrees is half of 150 degrees. 150 degrees is one of our special angles. Now, so I'm going to use a half angle identity for tangent. But which one? We have 3 different versions for the half angle identity for tangent. Well, out of the 3 versions, the last 2 versions for the half angle identity does not involve plus or minus symbol, right? So that means I don't have to worry about choosing the correct sign. So it seems a little simpler to use one of those later half angle identities for tangent. So I'm going to use this one. Tangent of a over 2 is equal to sine of a over 1 plus cosine of a. All right, so here we go, guys. Now, you didn't have to use that identity. You have 3 different options, so you can use whichever one you want. So what they gave me is tangent of 75 degrees. But tangent of 75 degrees is equivalent to tangent of 150 degrees divided by 2. Oops, what's that? Hold on. 150 degrees, I wanted degrees there, not squared, divided by 2, right? So I'm going to use my identity, and you can see that my numerator here is 150 degrees, so that's what I'm using for A, right? My A value is 150 degrees. All right, guys, let's go for it. So then this is sine of 150 degrees, okay, over 1 plus cosine of 150 degrees. I hope that's clear. Now, 150 degrees, my reference angle is 30 degrees. So therefore, sine of 150 degrees will be equivalent to, remember 150 degrees is in quadrant 2. So sine of 150 degrees will be equivalent to sine of 30 degrees, which is 1/2, right? Cosine of 150 degrees, remember again, 150 degrees is in quadrant 2, and cosine's negative in quadrant 2. So cosine of 150 degrees will be equivalent to the opposite of cosine of 30 degrees. So then this would be negative, that's the opposite part, root 3 over 2. Okay? So this is the expression that we have to simplify at the moment. So then this is, let's see, you know what we can do is we can multiply everybody by the LCD. The LCD in this example is 2. So if we multiply everybody by 2, right, we'll get, let's see, 1 over 2 minus root 3. Cool. What we should do at this point, though, is we should rationalize. So let's rationalize by multiplying by the conjugate of the denominator, 2 plus root 3. Like that. Okay? Cool. In the numerator, you'll get 2 plus root 3, right? And in the denominator, you're going to get 4 minus 3, which is just 1, right? So then this is 2 plus root 3 over 1. So tangent of 75 degrees is exactly equal to 2 plus root 3. That's an exact value. Man, this is so much fun. I hope you're having fun like me. All right, let's go to the next example. Okay, guys, example 3. Find sine of s over 2, cosine of s over 2, and tangent of s over 2 given the following information. Okay, the next pieces of information I'm about to give you is given to you. Okay, the first thing is s is between pi and 3 pi over 2. Okay, and then what the other thing they're giving you is cosine of s is equal to negative 3/7. Okay, guys, take what they gave you and find sine of s over 2, cosine of s over 2, and tangent of s over 2. Let's start with sine of s over 2. Remember this, guys, or just keep in mind, if they're telling you s is between pi and 3 pi over 2, what quadrant is that? Quadrant number 3. Very good. That's going to help us choose our signs later on, okay? All right, let's go for it. Sine of s over 2. All right, sine of s over 2 is what they're asking me to find. I know that that's the same thing as plus or minus the square root of 1 minus cosine s over 2. So you can see all I need to do then is plug in what I know, what they gave me for cosine of s. All right, let's go for it. So that this is plus or minus. We'll figure out the sign in just a minute. 1 minus negative 3/7, and then this is over 2. Okay, so again, some arithmetic to do. Plus or minus the square root of 1 plus 3/7 over 2. Man, this kind of work is really brushing up on our arithmetic, isn't it? It's probably a good thing that it is. So then this is plus or minus the square root of, let's see if we can do this. This is going to be 10 over 7 times 1/2. Okay, after you add these fractions here, you'll get 10 over 7 divided by 2, which is the same thing as multiplying by 1/2. All right, cool. So then you're going to get plus or minus the square root of 5/7. The square root of 5 over the square root of 7. In order to rationalize this, you're going to want to multiply the numerator and denominator by the square root of 7. Okay, cool. So then what we get now is plus or minus square root of 35 over 7. Now it's time to choose the correct sign. Now, this is what we know already. We said it earlier. Now, this is really important what I'm about to say next, okay? Because we can make a mistake very easily here. We know that s is between pi and 3 pi over 2, right? That's what they told us in the very beginning. But this is function value that you and I found is not sine of s. It's sine of s over 2. So I know where s lives. What about s over 2? Well, s over 2 will be between pi over 2 and 3 pi over 2 over 2. In other words, what I'm saying is divide everybody by 2. Divide everybody by 2 to find out where s over 2 resides. So s over 2 then resides this half angle resides between pi over 2 and 3 pi over 4. Which quadrant is that? Yes, quadrant number 2. Now, in quadrant number 2, sine is positive. That means I'm taking my positive root. So sine of s over 2 is positive root 35 over 7. You see how dangerous this could be, right? In the original given information, they gave you s is in quadrant 3. But we did not find sine of s. We found sine of s over 2. So you have to figure out, okay, thank you for letting me know where s is, but I need to know where s over 2 is. So that's why I was doing this business over here of dividing by 2 to figure out where does this angle reside. Okay? All right, okay, guys, let's go for cosine of s over 2. Okay, cosine of s over 2 is also what they're asking for. And by the identity, we have plus or minus a square root of 1 plus cosine of s over 2. Okay, guys, we just finished saying that s over 2 is in quadrant 2. Therefore, cosine of s over 2 is negative, right? Because cosine of s over 2, because cosine is negative in quadrant 2. All right, cool. So let's plug in what we have. Now, cosine of s is given to us. Cosine of s is given to us in the problem. It is negative 3/7. So then this is going to be minus 3/7 over 2. The arithmetic part of this is going to be very similar. So then it's negative, what is this, 7/7 minus 3/7, which is 4/7. And then divided by 2 means times 1/2. So we have negative square root of 2 over the square root of 7, correct? And then we can rationalize by multiplying by the square root of 7. Okay? Move this up a little bit here. So then what we have is cosine of s over 2 is equal to negative root 14 over 7. Cool? That's what cosine of s over 2 is. All we need to find now is tangent of s over 2. Let's go for it. Okay, guys, tangent of s over 2 is what is being asked of me. Now, we know that there's 3 different versions of the half-angle identity for tangent. But in order, you know what I'm thinking? In order to use only the given information, which is cosine of s, I am going to use the very first one, the very first identity for the half-angle identity for tangent, which is plus or minus the square root of 1 minus cosine of s over 1 plus cosine of s. You can use one of the other identities. You could even use a quotient identity, sine of s over 2 divided by cosine of s over 2. But I'm trying to not use derived information just to be more cautious. I want to use only given information just in case I made an error when I found sine of s over 2 or cosine of s over 2. I hope that makes sense. I hope my me being cautious makes sense to you. All right, so plus or minus 1 minus, the square root of 1 minus cosine of s is negative, what is it, guys? Negative 3/7. That's right, negative 3/7. Okay, and then this denominator is 1 plus negative 3/7. Okay. So then this is plus or minus. Oh, you know what? We can choose the sign right now. We said earlier that s over 2 is in quadrant 2, and tangent's negative in quadrant 2. So this will be negative. And then this is going to be, let's see, the numerator is going to end up being 10/7. And the denominator is going to end up being 4/7. All right, cool. So then this is going to be negative 10 over 7, the square root of 10 over 7, of course, times 7 over 4, right? So then this will be equal to negative, 7's divide out, and then you're going to get the square root of 5 over 2, right? So then this is going to be equal to negative square root of 10 all over 2. all right, after rationalizing. All right, you guys, this is what tangent of s over 2. And you should have gotten the same answer had you used a quotient identity to evaluate tangent of s over 2. All right, or any other identity. All right. Okay, guys, in example 4, they want you to simplify the following expressions. Okay, let me give you both expressions now. The very first one is plus or minus the square root of 1 minus cosine of 8x over 2, like that. Okay, so we'll simplify that. And then the next one is plus or minus the square root of, and then they have 1 minus cosine of 9 beta over 1 plus cosine of 9 beta. Like that. Okay. This is beta, guys. Okay, if you can't read that. Okay. All right, let's go for the first one. Okay. Let's simplify part A first. Okay. So this is what I want you to notice. I want you to notice that sine of a over 2, okay, is equal to plus or minus the square root of 1 minus cosine of a all over 2, right? Isn't that our identity? You're like, I'm not sure because I can't read your writing. Okay, hold on. Make this look like cosine. Okay, cool. Isn't this our identity that you and I derived earlier in this lesson? You should be saying, yes, it is. So this is what you and I derived already. And notice that this on the right-hand side is what's given to me. It's of this form right here, right? Where this a right here is 8x, right? Look at this, plus or minus the square root of 1 minus cosine of a, where a is 8x. So that means when I rewrite all of this expression that they gave me, I am going to rewrite it like the left-hand side. And when I get to this a here, a is the same thing as 8x, okay? So let's do it. Let's see if we can do it. This is equal to a sine of a over 2, which would be 8x over 2. So then this whole expression that they gave me is just the same thing as sine of 4x. Isn't that cool? Let's do the next one. Let me just kind of separate this from my work, all right? Now look at this. This identity, or excuse me, this expression that they gave me for part B looks like this, doesn't it? Doesn't it look like this identity? Tangent of a over 2, right, is equal to plus or minus the square root of 1 minus cosine of a over 1 plus cosine of a. The expression they gave us looks like this, doesn't it? It looks like the right-hand side of this identity, right? So that means we can rewrite what they gave me as the left-hand side. In this case, this a right here represents 9 beta. So when I get to writing a, I'll rewrite that as just 9 beta. All right, so then this is what we have, everybody. We got tangent of a over 2, which just means 9 beta over 2. That's it. That's the given expression that they gave me here is the same thing as tangent of 9 beta over 2. Pretty cool. All right, let's go to example 5, the last example for this section. Example 5, verify that this is an identity. Okay, guys, supposedly this is true for every value, for any value of x. You and I have to decide which side we want to work with, okay? I'm going to say the left-hand side. You know why? They both, the right-hand side does look a little more complicated, but the left-hand side gives me something to work with because I have a half-angle identity for tangent. So the left-hand side is tangent squared of x over 2. You know, that means tangent of x over 2, quantity squared. You know that's what that means? And you and I have an identity for tangent of x over 2. It's it's plus or minus 1 minus cosine of x over 1 plus cosine of x. That's what tangent of x over 2 is. But then we have it being squared. Now, when you say it's being squared, that means it's going to be positive, and it also means that the square root is gone. So then you end up getting 1 minus cosine of x over 1 plus cosine of x. Cool. I think that's a good point at which to stop. What I've realized so far is the left-hand side turned out to be 1 minus cosine x over 1 plus cosine x. And what I'm thinking of doing right now, I hope it is fruitful, is I'm hoping to go to the right-hand side of the identity they gave me and show that the right-hand side is also equal to this expression. Okay, this is what they gave me for the right-hand side. All right, let's see if I can start playing with this. Let's see, what should we do? What if I wrote everything in terms of sine and cosine? So secant of x is 1 over cosine of x. And then what I can do next is I can multiply everybody by the LCD, which is just cosine x. Okay, so let's see. If I multiply this by cosine x, I just get 1. Plus. When I multiply this by cosine x, I get cosine squared of x. Minus. When I multiply this by cosine x, I get 2 cosine x. All right, what about this denominator? When I multiply this by cosine of x, I get 1. And when I multiply this by cosine x, I get cosine squared of x. All right, cool. Okay, I moved the screen up a little bit. All right, watch this. I'm gonna rewrite the numerator as 1 minus 2 times cosine x plus cosine squared of x. I just rearranged my terms a little bit. And then the denominator is 1 minus cosine squared of x. You know what I'm thinking about doing? I noticed that the numerator is a perfect square trinomial, so that it factors really nicely as a square of a binomial, to be exact. And then this down here is a difference of 2 squares, so that also factors really nicely. So the numerator factors as 1 minus cosine x times 1 minus cosine x. The denominator factors as 1 minus cosine x times 1 plus cosine x. So you can see we can divide out common factors, and then what I'm left with is just 1 minus cosine x over 1 plus cosine x. Is this the same expression that I got the left-hand side to equal? It is, right? So then we showed that the left-hand side is equal to 1 minus cosine x over 1 plus cosine x, which is, we showed that's also what the right-hand side is. So we did. We verified that the statement they gave us is an identity. All right, you guys, we made it. This is the end of 5.6, end of this video lesson, but it's also the end of chapter 5 entirely. So we have finished chapter 5. We have derived all of our identities for this course. I strongly recommend that you get all of your identities on one sheet of paper on one place, one location, so that you're not flipping through your identities throughout your notes. I'm sure you have tons of notes. All right. And another thing I want to recommend is back in 5.2, we were verifying identities. And on page 245 of your textbook is an amazing list. It's called Summary Exercises on Verifying Trig Identities. There's like 34 different identities and you have to verify them. This is extra practice for verifying identities. I know we need the extra practice. So when you get some extra time, look at those on page 245. All right, everybody. Happy studying. I'll catch you soon in chapter 6.